All right, we're going to talk about a little bit more about secret codes and how they relate to the idea of a function. So by now you should have completed your 4.1 investigation, where we went through and we were looking at different secret codes and how those secret codes created a relationship between an input value and an output value. If you have not gone through and done your investigation, I suggest that you pause this video and go back and do that now. Another activity that is going to be really helpful in kind of formulating these ideas is that Desmos activity called Guess My Rule. It's another really great way to get kind of more familiarized with the ideas of function, domain, and range. So we can think about so this is 4.1 secret codes. And it would be great if you guys followed along and took notes along with me. This will be helpful in solidifying these ideas. So when we were looking at these codes, we can kind of think of that as a set of ordered pairs. So a code is a set of ordered pairs. And remember, ordered pairs are written like this, where we have parentheses. And so far we've looked at this. We've looked at X and Y. Another way to think about that is we have an input and we have an output. So for example, in that first code that we used in the investigation, the pairs were, for the input A, our coded output was Q. For B, my coded output was R. For the input Z, the coded output was P. And so on. You can go through each of them and write those all out as ordered pairs. So this set of ordered pairs, the set of ordered pairs is called a relation. So this is one of our vocabulary words, relation. And the set of inputs is the domain, while the set of outputs is the range. So the domain is our set of inputs. So that would be the first letter written in the ordered pair. It would be our X values. So set of inputs. And then range is our set of outputs. So I know that's a little bit confusing because we looked at a different definition of range earlier when we were looking at data. We were looking at range in the context of like maximum and minimum. So we gotta just kind of shift gears here, and we are thinking now about range as our set of outputs. So that second value written in our ordered pair, our output or our Y values. Okay, so we saw in our investigation that a relation serves as a code with a special property. So no input can be paired with more than one output. So in that second code that we used in the investigation, several of the inputs had multiple outputs, which made things very confusing, and it made it very unclear on how to encode a message, because for example, M was coded to be C as well as T. So I'm not sure what to use, and on the other end, when someone wants to decode the message, they wouldn't be able to. So when a relation has exactly one output for each input, that is called a function. Again, if you didn't do that Guess My Rule activity in Desmos, it would be a good idea to go back and take a look at that now. Because it kind of covered that idea that for every input, there is exactly one output. Okay, so let's write that down. So a function relation in which every input has exactly one output. They also call this a one-to-one relationship. Okay. And specifically in the context of like secret codes, for a code to work, it has to be a function, And this kind of relates to one of your check for understanding questions in how codes are used all over the place in our regular everyday world. And this is where mathematics can get really exciting and interesting, is the field of cryptography, of using codes to encrypt certain kinds of information. And this can be used all over the place. It's used in computer science, it's used in ATMs, it's used in passwords, it's used in biotechnology when you're sending information about different healthcare information. This field of cryptography is really, really important, and it all kind of boils down to this idea of a function, where we have to have a very clear code that has a one-to-one relationship. Every input has exactly one output, okay? So let's go through, and so what we've looked at so far are relationships that dealt with inputs that were letters and outputs that were letters. We're now going to take a look at numbers when the input is a number and the output is a number, okay? Let me get this written down real quick and we'll be right back. Okay, so we're going to practice looking at some relations that have numbers as both the input and the output. So we are going to state whether each table of values represents a function, and then we're also going to give the domain and the range of each relation. So each table here represents a different relation. First thing we're going to do is determine whether the relation is or is not a function. Remember, a function is when each input has exactly one output, okay? It can be helpful to kind of draw a little diagram, so that's what I'm gonna do. So in this first one, my inputs are 1, 2, and 3. And my outputs, let's put them there. Outputs are 2, 4, and 6. So 1, when I input 1, my output is going to be 2. When I input 2, my output will be 4. When I input 3, my output will be 6. Okay, So for every input, there is exactly one output. So yes, this is a function, is a function. Okay. And now let's talk about the domain and the range. So the domain is our set of input values. So domain is our set of input values. Our range is a set of output values. So our input is going to be these numbers right here, these numbers right there. Our output is going to be these numbers, okay? And the way we write that out is we say our domain is, so we put the colon there and then the squiggly brackets. Domain is 1, and we separate by commas, 1, 2, and 3. Our range is, in the squiggly bracket, 2, 4, and 6. Okay. All right, let's go on to the next one. So we have table B. Again, I'm going to draw a little diagram for us to see. So my inputs are 1 and 0 and 1, and then my outputs are 1, 2, and 5. So inputs, I'm going to put it in numerical order. So 0 and 1, and then my outputs are 1, oops, I'm going to do commas here. 1, I did it again, 2 and 5. 1, 2, and 5. Okay, and so 1 maps to 1, 0 maps to 2, and then 1 maps to 5. So this input maps to only one output. However, this input, my 1, maps to both 1 and to 5. So my input has more than one output, has 2 different outputs. Therefore, this is not a function. Not a function. But my domain will still be those input values, my input values. And you'll see that this table is written horizontally. This one's written vertically. It doesn't make a difference. You just might prefer one over the other. But okay, so again, my domain is my input values. So that's just 0 and 1. I don't need to write the 1 2 different times. I can just write it the 1 time. My domain is 0 and 1. And how about you pause the video and write out your range, and then I'll go over it in just a second. But take a minute and try to figure it out yourself first. Okay, so my range, again, is going to be my output values. My output values. So that's these numbers here, these numbers there, same thing, I just copied it down. So my range is 1, 2, and 5. Right, and then our last one. So how about you pause the video and give it a try. Try and draw out the diagram, decide whether or not it's a function, and then write out the domain and range. Pause the video, give that a try, and then come back and I'll do it with you. All right, so I'm going to first write out my diagram and then decide whether or not it's a function. So my inputs are these values up here, 1, 2, 3, 4, 5, 6. So I wrote those out, 1, 2, 3, 4, 5, 6. My outputs are 0. Everyone maps to 0. So 1, maps to 0, 2 to 0, 3 to 0, 4, 5, and 6. So you might be thinking that it's not a function. However, our rule does not say that every output must be unique. It just says that every input has exactly one output. Every input here has exactly one output. 1 does not map to 0 and to 1. It only maps to 0. Same with all the other numbers. Therefore, yes, this is a function. Okay? My domain are my input values. So that will be 1, 2, 3, 4, 5, and 6. My range is my output value, which is just 0. Right? And that covers that. This should be enough information for you to complete the learned column on your KWL chart, as well as your 4.1 check for understanding. But as always, if you have questions, I would be more than happy to answer them and would love to hear from you. You can email, you can call, you can text, you can leave a comment in Google Classroom. All right? Hope you guys are having an awesome day. I'll talk to you soon.